Namaste. Dear students, welcome back to our channel. So today we will explore another problem from the ISI MSTAT 23 paper. This is a subjective problem from the PSB paper. Okay, so this is the problem. So here a matrix N is defined in this following manner, that Aij is 0 whenever the indexes Ij have a difference greater than 1. When this difference is exactly equal to 1, that means I is j plus 1 or j minus 1. The value is 1, and when they are equal, that means all the diagonal entries are 2. Now the goal is to find out determinant of an for any n greater than equal to 1. Okay, so since this is a subjective problem, we have to step by step argue, and our argument should be clear. So we will actually try to do that in the upcoming slides. But first, let us explore how the matrix n looks like for defined choices of n. Okay, so these are the forms of an. Now, as you can see, A1 will just be 2. A2 is this kind of a symmetric matrix. Now, from A3 and A4 onwards, we can actually see the pattern that this is a kind of tri-diagonal matrix where there is 3 diagonal that are non-zero and the other diagonals are all 0 elements. So, to find out the determinants, what we can do is that we can actually evaluate it for initial choices of n, and first we try to see whether there is any pattern, right? Because we can start from the scratch. Okay, so suppose we compute the determinants for A1 up to A4. So A1 is obviously 2, it is nothing but the scalar itself. A2 is 3. Can you see any pattern? Well, if you can't, let's explore more. Now A3, as you can see, if we use the general Laplace expansion with respect to first row, then we will obtain this, right? So 2 times we will have this adjoint minus 1 times this 2 elements, the determinant of that. So by using Laplace expansion, we can actually see that in the determinant of a higher order matrix, the determinant of the preceding order matrix is coming. That actually indicates that there might be some presence of recurring relations. And actually that case turns out to be true. Like if you compute for A4, it is even more evident. As you can see that we will have 2 times the determinant of A3 minus 1 times the corresponding adjoint, but that actually again breaks down to the determinant of A2 or the second order principal block matrix. So that is very clear, I think, that this kind of recursion will hold in general. And also if you see, there's a very nice pattern that 2, 3, 4, 5. So kind of it is a very easy case that this should be the answer, right? And it actually turns out to be the answer. Just we have to argue more properly and more formally. So we will take a general an, and we can do a similar kind of expansion or the Laplace expansion, right? So if we expand in a similar manner, we will obtain these two terms. The rest of the terms will be 0. If you expand further, we will obtain 2 times the determinant of an minus 1 minus 1 times the determinant of an minus 2. So here is the recursion. Yes, that determinant of an is twice determinant of an minus 1 minus determinant of an minus 2. Now suppose we define a real valued sequence as nothing but the determinant itself. So suppose we define small n as determinant of capital N or determinant of matrix An. Then this sequence An satisfies this relation, right? Now can you see what this relation means? Well, I think you can, in the sense that this is nothing but meaning that a n minus 1, n minus 2, and n, these three are in arithmetic progression. And this holds for all n. So this can also be seen in another form as the differences of consecutive elements in n to be same. So an minus 1 is n minus 1 minus a n minus 2. Now in this manner, we can actually obtain the value of n for any n. How? Well, this difference will be same if we continue writing like this. And this will carry on till a3 minus a2, a2 minus a1. Now a2 and a1 we already know is 3 and 2. So the difference will always remain to be 1. Now these differences will help us a lot in calculating n. Can you guess how? Now again it is very simple actually. So we have the consecutive differences. How to find out the last term? That is nothing but using the ideas of telescopic sum, right? So an can be written as this. We just introduce the terms in between and cancel them. But in this kind of an introduction, obviously last term will be a1 because a0 is not defined, or you can define it to be 0. So that means an will be the sum of n minus 1 such elements plus a1. That is nothing but means an is equal to n plus 1. So this is a very nice kind of problem. Actually, it is using quite basic ideas of determinants, recursion, and similar things like that. Okay, so this is all about this video. Thank you for watching. If you like this video, do consider sharing the wisdom with your close ones. Hare Krishna.